Welcome to Western New England University. I'm Dr. Christian Salmon. I'm the chair of the Industrial Engineering Department, as well as your host in this short virtual open house that'll introduce you to our program, as well as what life would be like as an industrial engineering student at Western New England University. Since you cannot be on our campus, I'm going to be using some web-based materials from internal and external sources so that you can return to these sources and educate yourself on what is industrial engineering, what industrial engineering as a career path would look like, as well as what industrial engineering as a student at Western New England University would offer. We'll be looking at our curricula, as well as some of our laboratories. We'll take a short tour so that you can see the type of equipment that you'll be utilizing in your classes, as well as your separate research projects. I also invite you, if at any point you have questions about the program, feel free to contact me at any time. And you can find my contact information on the faculty page of the Department of Industrial Engineering and Engineering Management website. Let's start with, what is industrial engineering? And of course, for that we go to Wikipedia, where it says that industrial engineers use specialized knowledge and skills in the mathematical, physical, and social sciences, together with the principles and methods of engineering, analysis, and design to specify, predict, and evaluate results obtained from systems and processes. From these results, they're able to create new systems, processes, or situations for the useful coordination of labor, materials, and machines, and also improve the quality and productivity of systems, physical or social. Depending on the subspecialties involved, industrial engineering may also overlap with operations research, systems engineering, manufacturing engineering, production engineering, supply chain engineering, management science, management engineering, financial engineering, ergonomics and human factors engineering, and safety engineering, among other things. Wow, that's a lot. From that, you can see that industrial engineering is a very broad-based career path. A lot of job opportunities. And if we come to the website for the Bureau of Labor Statistics, we can see that not only are there a lot of job opportunities, but that there's an expected growth of 8%, which is above average, with a median salary of $87,000 per year. So industrial engineering has applications in everything from human factors to manufacturing to production control to quality control to supply chain and to safety. There's a very broad career waiting for you in industrial engineering of a pretty decent salary. So this is a place to start that career as a student here at Western New England University. Ensure that you're ready to enter this job market. Some of the areas that our curricula will cover while you're a student, from manufacturing to production planning and control to logistics and supply chain to human factors engineering to reliability and maintainability to project management to data analytics to quality engineering and even occupation. Our curriculum is designed around to prepare you as a student for entering the working world, where we have applied scientific engineering approaches to what you as an industrial engineer will be expected to know upon entering industry. And it can be seen by the courses that we have you take. Now, this is the freshman year, fall semester, spring semester. You notice that there are no industrial engineering classes because there are some basic sciences that all engineers must have as a foundation before they move forward in their engineering career. So we have the mathematics of calculus. We have the 2 semesters of calculus, we have the physics and the magnetism. But what you do see in here, interestingly, are the engineering courses 103 and engineering 110. That is part of what we call our freshman program. All engineering students go through the same freshman program, what we call the first year program. It's broken up into 2 semesters. It's very interesting and very innovative. It says here that in the first semester, design innovation and entrepreneurial thinking from day one is a cornerstone of engineering education at Western New England University. Our first year engineering program teams students up to design, code, and prototype a robot to compete in the bot battle at the end of the first semester. And in the second semester, that 105 and 110, data acquisition and processing, communications, ethical standards, and business skills are developed. Student teams design a product to improve lives through the application of smart technology. The prototypes are presented in the Emerging Engineers Expo at the end of the year. Now, first year, fourth year. That Engineering Expo, our senior design projects, which I'll explain a little bit later and give you some examples of them, are year-long projects that implement all of the skills that you've developed in the previous 3 years in your freshman, sophomore, junior years in partnership with faculty and an industry advisor. Some of these are done on our campus utilizing data and information from external experts. Some of these are done in partnership on the factory floor, utilizing our knowledge to improve a process, to minimize waste in a process. At the end of the freshman year, we have our freshmen present their SMART project alongside our senior design projects that are presented in a day-long poster presentation where families and industry are invited to view. Our sophomore semester is oriented around finishing up the foundations of the sciences that you need to excel with the engineering program. So we have the chemistry, we have the statics, the electrical engineering, differential equations, some of the basic university requirements as well, accounting, and now we have our first IE course. All engineering students take IE 212 or probability statistics. It is quite literally the foundation of what the industrial engineering does. Data collection and analysis is the foundation of the industrial engineer. It's data collection and analysis for decision making, for process improvement, and it is all based around a deep understanding of probability and statistics so you can infer an outcome from the data that you do have. It is now with our junior year that you dive almost exclusively into industrial engineering topics with work analysis and design, engineering economic analysis, mathematical programming for engineers, computer simulation design, industrial engineering computer applications, manufacturing processes, which is now being rebranded as an IE 314 course, quality control and engineering statistics, Lean Six Sigma for engineers, production planning and control. And linear algebra will no longer be a requirement. That is being replaced with a technical elective, which I'll explain in a minute. So in your junior year, we now give you the foundations beyond the sciences of chemistry and physics. We now give you the foundations of all the underlying skill sets the industrial engineer is expected to have. We move on to the senior year. We round this out with design and analysis of experiments, DOE, facility planning and material handling, which is a 2-credit laboratory where we visit physical production facilities. As a class, 1 week, we step out of the building, we go to a production facility, a distribution warehouse of some sort. We then come back to the classroom and we spend the next 3 or 4 weeks working on a problem directly related with that program, with that industry. Also have the first semester of our senior design project. This is where we introduce you to your project that you'll be working on for most of the first semester and all the second semester. We pair you as tightly as we possibly can with an industry mentor who is volunteering their time to help you define a project related to their industry. As faculty, we work alongside you in cooperation with the industry advisor to ensure that you have a robust project of which you conceive, define, set goals, set schedule, implement, follow through, finish, report. And that is done between IE 439 Senior Design Project 1 and in the second semester Senior Design Project 2. You'll notice now we also have technical electives and design electives. This is where you can start to follow areas of your own interest. In the IE department, we have a robust body of electives that you can choose from, including Introduction to Maintainability, Advanced Statistical Analysis, Occupational Safety and Health, among others. Computer-aided manufacturing if you choose to follow in a minor in manufacturing along with your IE degree. And you can even take those classes in other engineering departments as well. You can take them in the science department under certain circumstances. You can take them in the mechanical engineering department under certain circumstances. So our curricula is very specifically designed to give you the theoretical, classroom-backed experience body of knowledge integrated with a robust, practical, experiential experience both in the classroom, in the laboratory, and in partnership with industry, so that upon graduation, you can step into a robust career, first in industrial engineering, and then ultimately, as most people follow through their career path, into the management of a team, an interdisciplinary team of people within an organization. I wanted to give everybody a quick tour of some of our laboratory space. So we'll start here with the ATRANS, or the Center for Advanced Training, Research, and Naturalistic Studies. In here we have a couple of pieces of pretty sophisticated equipment. Here we have a driving simulator, where Dr. Matt Ramoser, one of his specialties in kind of human factors is understanding how people perceive hazards in situations such as when they're driving, particularly teen drivers or novice drivers. And we've used this equipment for a few senior design projects, including one where we studied the impact of concussions on the ability to react, recognize and to react to stimuli in a simulated driving environment. It's a pretty interesting study. So these are the types of things that we have our students work on in their, as part of their research projects. A few years ago, we extended that general idea into the area of aviation and flight. So we have here is a flight simulator. And we've used this for a very interesting project where we were studying the idea of whether we can increase the rate at which a novice pilot becomes proficient through capturing information of their activities through eye tracking technology, and then having them review the errors that they made. And does this or does this not have the impact on the rate at which people become proficient? It's a very interesting study. It was defended as a PhD dissertation last year. Another area where we believe it is critically important for our students, whether or not they're interested in manufacturing as a career, is in the area of additive manufacturing, and particularly in this case, the 3D printing. Now, the capability of 3D printers is increasing exponentially. It has been around as a technology for 20 years, if not longer. But the size and the resolution of these machines, the size is decreasing and the cost is decreasing, the resolution is increasing at such a rate that this is the future of manufacturing. Traditional subtractive manufacturing will probably never go away, and it still dominates American industry. But additive manufacturing is a skill set that you as a student must have upon leaving Western New England University. And so we're going to ensure that you have access to 3D printers, the technology and the software, and the ability to interact with these machines, utilize them, so that you have functional real-world knowledge of these systems. This space is a mock hospital suite that's predominantly utilized by the biomedical engineering department. But in some of my research, I have students working with human physiology equipment. Now, Patrick McKenna is going to be explaining his senior design project to you in a few minutes. But this is some of the equipment that we're going to be using on that project, where we are developing a new step test, which is used widely across the globe as a simple metric for human fitness. And there's some challenges with it. It's limited, where tall people have an advantage over shorter people, and lighter people have an advantage over heavier people. And so we want to develop, as a senior design project, a new step test that normalizes around the height and weight of individuals. And for this, we need to normalize everybody's physical capabilities. So we're going to be utilizing a treadmill. We're going to be utilizing some human physiology equipment to capture the capacity for their bodies to consume oxygen over a period of time. And so it's a very interesting project, and we're lucky to have this shared space with the biomedical engineering department, have access to it for not only faculty research, but also for student projects. Another area where we believe it is critically important for our students, whether or not they're interested in manufacturing as a career, is in the area of additive manufacturing, and particularly in this case, the 3D printing. Now, the capability of 3D printers is increasing exponentially. It has been around as a technology for 20 years, if not longer. But the size and the resolution of these machines, the size is decreasing and the cost is decreasing, the resolution is increasing at such a rate that this is the future of manufacturing. Traditional subtractive manufacturing will probably never go away, and it still dominates American industry. But additive manufacturing is a skill set that you as a student must have upon leaving Western New England University. And so we're going to ensure that you have access to 3D printers, the technology and the software, and the ability to interact with these machines, utilize them so that you have functional real-world knowledge of these systems. I have mentioned that the Senior Design Capstone Project is the culmination of a student's time here at Western New England University. So now I'd like to give you an example. I'll introduce it, but I'm going to have the student, Patrick McKenna, who's a senior now, is working on the project, explain it to you. As an introduction, we as faculty strive very hard to give our students a project that is relevant to their careers and hopefully in their areas of interest. I work in occupational safety and health, and one tool for assessing health of a workforce is a simple step test. It is a step people go up and down on at a certain cadence for a certain amount of time, and then compared to a large body of data, we can assess that individual's health as a function of their heart rate after that fixed exercise. Over the years, I've noticed a problem with this. Tall people have an advantage over short people. Heavier people have a disadvantage over lighter people. So I am working with Patrick McKenna to see if we can design a new step test that can be used for occupational safety and health that normalizes for everybody's body shape, size, and weight. It's a challenging project, directly applicable to occupational safety and health, utilizing a large number of industrial engineering tools, including computer simulation, design of experiments, and human physiology and human factors. So with that, I'll have Patrick present a summary of his presentation to you so that you can see the level of sophistication that we ask our students to engage in when it comes to their senior design project, which utilizes as many of the industrial engineering tools that we offer in the 4 years of your time here at Western New England University.
Hello, my name is Patrick McKenna. My project is simulating human output during a step test. This project focuses on human factors engineering and computer programming for engineers. The industry standard which is relevant to this project is ISO/TC 159. This covers the standardization of matters related to human characteristics and abilities. The scope of this project is to develop a mathematical model which can simulate human output during a step test. Right now, there exists a step test which factors in the height of the test subject, but not the weight. The objective of this project is to develop a mathematical model that can simulate the results of the YMCA step test. In the future, this model will be used to help design, test, and validate a new step test that includes factors of both height and weight. Now, you may be wondering, what is a step test? Well, a step test is just a cardiac fitness test designed to evaluate somebody's physical health. It's a convenient way to estimate a person's VO2 max. VO2 max is the maximal oxygen uptake of a person during intense exercise. VO2 max testing is typically executed using a treadmill and a mask to find the oxygen as a function of heart rate. This process is not practical for testing more than a few subjects, as it is really inconvenient to attach the mask and get the test subjects onto the treadmill. The current existing step tests are the Harvard step test, the Queens College step test, the YMCA step test, and the YMCA modified step test. The YMCA modified step test factors in the height of the test subject. For this project, I will be focusing on the YMCA step test. The height of the step used in the YMCA step test is 12 inches tall. This step test follows a cadence of 96 beats per minute, which is equivalent to 24 steps per minute. This is a submaximal test which means it only lasts 3 minutes. It should not go to the point of exhaustion. Once the 3 minutes have passed, the test subject's heart rate is recorded and compared to the proper chart. For example, a 30-year-old woman with a heart rate of 125 would be in poor physical condition. The preliminary model design begins by taking a 50th percentile woman and using an anthropometric table to determine the length of the links, as you can see to the right. Then a human model will be created using MATLAB. Using Simulink, this model can be simulated to step up and down a block. This model will then be modified to simulate the YMCA step test. Using MATLAB Central File Exchange, I have downloaded a walking robot simulation. This model can be edited through Simulink to change the length of the links, adjust the knee joint, and add a 12-inch step. In the future, we want to normalize the model so that everybody is doing the same amount of work biomechanically. Without the mathematical model, this would mean testing thousands of subjects. This would take years and years to accomplish, but with the mathematical model, it can be simulated in seconds. This can be done by changing the height of the step for each person, or maybe even changing the cadence for each person. That can be done with a click of a button. The end goal is to isolate the physical fitness as the only variable. Thank you for your time.